Welcome to Lesson 13 of the Ubuntu Mastery course. This is where we lock down the single most attacked service on your host. SSH faces thousands of brute force attempts daily, and our answer is uncompromising. ED2 519 keys only, no passwords, no root login, and a Harden SSH config drop-in that any Ubuntu box can ship to production. Lesson 12 already gave us UFW rate limiting. Lesson 14 will layer and fail to ban and crowdsec. But right now, we harden SSH itself, and we verify it with SSH audit before we trust it. Step 1 of hardening is killing password authentication entirely, and that starts with generating an ED2 519 key pair on your laptop, never on the server. ED2 519 gives you a 68-byte public key, fast verification, a modern curve, and zero patent baggage. Always set a passphrase. SSH agent will cache it so you type it once per session. Then push the public half with such copy ID. It handles the 700 on SSH and 600 unauthorized keys that SSH strictly requires. And critically, test the key login in a second terminal before you ever touch password authentication. Lock yourself out once, and you'll never forget this rule. With keys in place, you lock down the daemon itself, but never edit the upstream SSH config. Ubuntu's main config includes .conf at the top, so a drop-in always wins and survives apt upgrades cleanly. Ship one file, 99hardening.conf, with these 10 settings: no root, no passwords, no keyboard interactive, 3 auth tries, 30-second grace, idle kick at 10 minutes, and forwarding off unless you explicitly need it. Then the golden rule, SSHDT to validate syntax, systemctl reload SSH, and keep your existing session open until a second terminal confirms login works. Once the global defaults are locked down, you carve out exceptions with match blocks, and they must live at the end of the file because SSHD reads top-down and match runs conditionally on user, group, or address. 5 patterns cover almost every real-world need. An rsync-only group with force command and no TTY, an OPS group allowed to agent forward for jump host hops, admins restricted to LAN address ranges, an Ansible deploy account pinned to a single deploy script, and deny groups at the top for clean offboarding. Then verify the logic deterministically with SSHD TC, simulating the exact user, host, and source address. Never guess what match resolved to. Prove it. Now, a hard truth about port choice. Moving SSH from 22 to 22.2.2 is security theater. Modern scanners sweep the full port range in minutes, so obscurity buys you cleaner logs, not safety. Keep 22 unless you're behind a WF. The real win is forcing modern crypto. Curve 25519 for key exchange, Cha-Cha 20, Poly1305, and AES GCM for ciphers, encrypt then MAC for integrity, and ED2 519 host keys. That single drop-in rejects every legacy bot and weak client on the planet. Then verify externally with SSH audit from your laptop. You want an A grade, not your own opinion. Now let's layer one more factor on top of keys. TOTP through PAM. The threat model is simple. Somebody steals your laptop, gets your private key, and walks straight in. With MFA enabled, they also need the 6-digit code rotating on your phone every 30 seconds. Install libpam Google Authenticator, add the auth line at the top of SSH, etc., pam.e SSHD with nulloc during rollout, then flip SSHD to use PAM. Yes, KBD, interactive authentication, yes, and crucially set authentication methods to public key, keyboard interactive. That comma means key and TOTP, not or. Each user runs Google Authenticator once, saves the emergency codes, and you test from a second session before you ever log out of the first. Hardening SSHD is only half the job. If you're not reading the logs, you won't know when somebody's probing the door. Because we set log level verbose back in lesson 11, Journal now records the key fingerprint on every accepted public key line, which means you can match exactly which key from authorized option keys let someone in. Bookmark these 6 queries. successful logins today, failed attempts, top offending IPs to feed CrowdSec, lateral movement via last and last log, who's connected right now, and SSH audit run from CI to catch config regressions. Forward all of it to Loki and alert on more than 5 failures from one IP in a minute. That's the handoff straight into lesson 14. Now here's the uncomfortable truth. Everything we've built still relies on authorized keys, and that model breaks the moment you cross roughly 10 hosts and 5 users. 5 admins across 50 hosts is 250 key entries to chase. New hire, you edit 50 files. Someone leaves, you edit 50 more, and pray you got them all. SSH fixes this cleanly. You generate one EDI 25519 CA key, push only its public half to every host via trusted user keys, and then sign short-lived 24-hour user certificates on demand. Offboarding becomes trivial. You just stop signing and their cert expires by tomorrow. That's the next tier, and it's exactly where SSH Hardening Mastery picks up. And that's exactly the bridge into this slide. What you've learned in lesson 13 is the production baseline. Keys only, no root, max auth tries clamped, match blocks for your admin group, and that will hold the line on a small fleet. But once you're running SSH CA with vault-backed signers, YubiKey resident certs, proxy jump bastions, PAM stacked MFA, and Appermore profiles sandboxing SSHD itself, you need the full 13-lesson deep dive. The honeypot on 22 pattern in L10 alone is worth the trip. Links on screen, dargslan.com/courses/SSH Hardening Mastery. Before we wrap, the gotchas, the 5 places this lesson will bite you in production. Number 1 is the classic. You set password authentication no, reload SSHD, your key auth is misconfigured, and now you're locked out. Always keep a second SSH session open while you edit SSHD config, and verify the new session works before you close the first. 2. Authorized keys at 644. SSHD silently refuses it, HMOD 600, or just use copy ID. 3. Match blocks belong at the end of the file because everything after a match stays scoped to it. 4. Drop-ins must end in .conf, not .txt. Verify with sudo sshdt. And 5. Don't mix allow users with match and expect match to override it. Allow users is evaluated first. With the gotchas behind us, here's the recap. 6 skills that, taken together, harden SSH to production spec. You generate EDI 25519 keys with the right permissions, ship a drop-in that kills root and password auth, and bounds idle sessions, carve out exceptions with match blocks, enforce modern ciphers and verify with SSH audit, optionally bolt on MFA through PAM, and run daily audit queries to surface failed IPs. Next lesson, 14, we layer fail2ban and CrowdSec on top. Dynamic blocking that feeds off the very logs you just learned to read. SSH is locked down. EDI 25519 keys, hardened SSHD, match blocks, audit, and MFA all checked off. But hardening the daemon only gets you so far. Attackers will still hammer port 22 looking for a crack. So in lesson 14, we go dynamic. Fail ban watching your logs and dropping bans into UFW. And CrowdSec pulling in crowdsourced threat intel so you're blocking known bad IPs before they ever touch your server. Run next lesson and let's keep stacking the defense.